So as I told you in the introduction session, we will go step by step through all of the stages of essentially developing and publishing a paper. And so we're going to start with data. So before you can do anything, you have to get data somewhere. And so today we will talk about data sources, data quality, types of data. And so some of this stuff you probably know. In fact, I'm pretty sure that most of these things you know. But hopefully there will be still enough new stuff here. And so that's what we'll talk about. By the way, I did look at your homework, at your research questions and hypotheses. Generally very good, very good. But some of the sort of recurring, not really errors, but perhaps things that were not precise enough or perhaps not, perfectly formulated are related to today's topic. And so throughout the lecture, I will be from time to time going back to the homework, and we'll be talking about some of the, as I said, things that perhaps could be improved in your homework, and we'll be explaining in more detail why some of the ways some of the hypotheses were stated is not the best way to put it, and what the better way would be if we looked at it. So before we get into the data, a very simple question of what is science, or what science is not. I'm absolutely sure that all of you know what science is, but just to be sure, again, because there were at least a couple of points in some of your homeworks where the way you phrased the hypotheses and research questions, it was not necessarily a very scientific method to approach, the question. And so usually when we talk about science, and that's what your dissertation should be, usually it has to be based on the scientific method. It should be based on hypothesis testing. You should be estimating the effect size and probability of being wrong. And then you should always keep in mind sort of the type 1 and type 2 errors. And so I'll talk about each of these in a little bit more detail. So when it comes to scientific method, usually what that means, as you probably know, is that it's all about testable hypotheses. Like, for example, some of my colleagues back in Ukraine, for some reason, they sort of publish papers that deal with, for example, issues of current challenges and future opportunities of something, for example. And so current challenges and future opportunities of something, it's not really science. It's more, it may be analysis, it may be sort of, insight, but it's not science by definition, because science, it's not about what I think my challenges are or how my company needs to survive. It's something else. So in engineering, I guess it could be, like you're trying to figure out why that device is not working, and then you develop a better, way to wire the device. So that would be useful, but it's not science. So in science, it always has to be a hypothesis and a test of that hypothesis. And so usually we are talking about testing things like, for example, a hypothesis that X correlates with Y, or relates with Y in any way, or maybe is different from Y, or X has an effect on Y, or mediation or moderation. So something what you did for the homework. And it's very important that you have that clearly specified hypothesis, because you need to test it. It must be testable. And so if you don't have a testable hypothesis, it could be still maybe, useful discovery, but it's not science in the traditional way. So it's very important that that relation should be tested. And so here is something that you may not know. So here are some of what I call science sins. And let me see if you've heard these very, very common examples. Like, for example, do you know about the teacup in the orbit? Anyone knows what that is about? Like if I say there is a teacup in an orbit. So this is a classic example of a sort of pseudoscience. And the reason for that is that, the story goes as the following. I'm telling you that there is a teacup in the orbit of Jupiter. And so it sounds like a hypothesis, it sounds like a discovery, but it's not science because we cannot test it. So we don't have a technology at this time to go and scout the entire sort of, surrounding of Jupiter to see if there is that teacup in that orbit. Maybe there is one, maybe not, but it's not something that we can test. And so for that reason, even though it sounds like a testable hypothesis, and even though it sounds like a discovery, in reality, that's not something that we can call science, because there is absolutely no way we can test that hypothesis. And so that's a problem. Just one second. Sorry, my family is having dinner and I needed to ask them to be a little quieter. Second problem is the little green man. Do you know what the little green man sort of paradox is? There is even a Wikipedia article about the little green man. So again, this one is sort of an assertion that everything we do, everything we believe, everything, every action we take is governed by a little green man who sits inside of our head. And the little green man doesn't want to be discovered, and because he or she is omnipotent, he makes himself invisible every time we are trying to see it. So every time that somebody wants to test the hypothesis and open somebody's skull, the little green man makes himself invisible. And so it's a perfect theory because, yes, it perfectly matches the observations. Whatever I do, when I raise my hand, well, it must be the little green man who made me do it. And we know that he cannot be discovered, so the theory cannot be disproven. And so again, it sounds like science, and very often you see research of that kind. But again, it's not science because the hypothesis is untestable, because the way the theory is phrased, it basically precludes testing. And so a very good example, I put it as a separate example in this case, but a very good example of the sort of the little green man and the teacup in the orbit since is basically Freudism. You know who Sigmund Freud is, right? The famous psychologist from about 100 years ago. So he was basically one of those, almost like a, poster child, or he's not a child, but, one of those symbols of science. But later he was fully discredited, and not because his theories were wrong per se, but because they were not scientific. So I'm not sure how much you know about Freud. I took a bunch of psychology classes and obviously always would cover him. But, and he talked about all kinds of things, dreams and, the development of the individual. But much of his sort of theories were hinging on this, everything we do is governed by our sort of unconscious suppressed ideas or desires. And so he was the father of the psychoanalysis. And so he would look at you and, try to understand your problems. And then he would explain them with sort of stories. Maybe you had some secret crush on your mother and you were afraid of your father. Or maybe, there was some other perhaps abuse or perhaps something that happened in your past. And this is why maybe you don't love your spouse enough, or this is why maybe you're not confident enough. And so all of those explanations kind of sound logical when you listen to them. But the problem with those theories is that they're not testable. Again, that's the same thing as with the little green men. So it's, by definition, subconscious. And so as a result, it's not really something we can test empirically. So it's not something that we can devise an experiment and test it. Like, for example, he was big on interpreting the dreams. And so like the famous example is that when you see a dream of a train going into a tunnel, that's presumably, a manifestation of your, hidden repressed sexual desires. And so maybe it is, maybe it's not, but it's not really something we can test. I suppose we could have 1,000 of people and maybe, abuse some of them in childhood sexually and don't abuse others, and then measure how frequently they have the dreams of a train going into the tunnel. And maybe, using that as an experiment, we can say, oh yes, if you had these kinds of experiences in the early life, these are the kinds of, tendencies and dreams you will have. But I mean, it's basically unrealistic to test it. And so while it sounds scientific, in reality, it's more of a kind of philosophy or theorizing or maybe just, plain talking, but it's not science in the traditional sense. And so by now, Freud is mainly, studied as, as someone who was big at some time, but not as a scientist in a traditional sense. So not to mention, yes, somebody said, not sure IRB would approve it. Even if IRB did approve it, I mean, theoretically or practically, it probably would be impossible to, to test. And so that's one of those examples where you literally have pseudoscience. It sounds like science, but in reality, it's not really science. And so it's important to keep that in mind. So one of the problems I saw with some of your homework assignments, there were some very interesting sort of hypotheses or ideas, but the constructs on the, in question were such that I'm not sure it would be possible to, to measure them in a valid and reliable way. And we'll talk more next time about measurement. but there were some things that kind of make sense on the face of it. But I wonder if it's even possible to sort of, measure and maybe even define some of those things. It's kind of things that we know, but not necessarily are easily measurable. So, and that's those examples. So then also when we talk about science versus sort of philosophy, like for example, I tell this story. My wife was a psychology student at some point, and one of the projects she was involved in as a teaching assistant or research assistant, it was looking at the differences in education attainment or education success in kind of poor versus rich families. And so there was like a grant of something like $1.2 million or something. And those students had to go literally door to door through some poor neighborhoods and basically conduct interviews to see if, how much parents spend time with their children, helping with homework or reading books. And then they were looking at the performance in school of those children to see if, how much parents spend time with the children affects the performance, academic performance. And sure enough, in families where parents spend a lot of time with kids, where parents are a little bit more sort of, stable in their work and can afford to spend time with their kids do better in school. And so my response to that was like, did you really need $1 million to answer that question? Like my grandma knew that. So, but the difference between my grandma or my mom is that she would say, well, if you get good grades, you'll get a better job. Well, we kind of know it. But science could be still addressing that same question, but the difference will be that it will be collecting proper data. It will be calculating, for example, correlation between GPA and income. And let's say the correlation is, for example, 0.21. So we get a precise estimate of the effect size. We would calculate the p-value, as you probably know from some other courses, so the probability of essentially being wrong. And so we can say that, the p-value for this correlation is 0.02, which means, there is a 2% chance that we may be wrong in a sense that maybe there is no relationship. And so that's very, that's how science is different from simply, stating a relationship. So, and then also very important to keep in mind type 1 and type 2 error. You probably know what they are. I'll just repeat one more time. So type 1 error, that's a false positive. You think that there is a relationship when there is really no relationship. And type 2 error is the opposite. There is, in real life, there is a relationship between A and B, but you fail to detect it. The question I have for you is, which of the two do you think is more common? Which of the two we are more likely to commit? Or looking at all the published research, and some people say that up to 80% of it may not be replicable, meaning that it's perhaps not true. So
type 1.
Which one is it? Yes, Joe.
Type 1.
Yes, type 1. Type 1 is extremely, much more common. Do you know, Joe, why?
Because the larger your sample size, the more it's going to look like it's positive when it's really not.
That's true, but I mean, I don't think we have a problem with sample sizes being too large. Definitely sample size can mess up our conclusions. But why are we making that error more often?
Yeah, they won't publish. That's it. Yeah.
Is it related to variables?
Conflict of interest, exactly.
Yeah.
So unfortunately, researchers or journals like studies that find an effect. And we have this intrinsic sort of, conflict of interest. On the one hand, I want to report what's true. But I know if I don't find a relationship, the study will have a very low chance of being published. And so what happens, as one famous researcher once said, we torture the data until they confess. So you try, you don't find the significant relationship. So then let's drop this variable. Let maybe add this variable. Oh, this outlier looks a little strange. Maybe let's delete this outlier. Maybe let's do something else. And so you massage the data until you get the result that you want. So, but yes, sample sizes too large can definitely lead to the conclusion that everything's significant. And actually, we do have that problem in X culture. So we have huge amounts of data with tens of thousands of cases. And at that level, just about everything comes out significant, statistically significant, which increases our type 1 error as far as the conclusion of, for example, association. So there are more ways to make discovery or create knowledge. Science is technically knowledge creation, right? So we create new information that was not available before. But not every information or knowledge creation is science. And so here are some of the examples of, sort of useful, insightful activities that perhaps not necessarily are science. Like, for example, history. So history can be science-based. You may have a theory that maybe, let's say, something happened during the Second World War and this is why something else happened. And so you can then have a hypothesis that perhaps this individual played a critical role, and this is why. And so you go to the archive, you look for the records, you look for the maybe, I don't know, some documents. And so those documents support your theory. So in that case, it's basically science. But in many cases, history is just a description of what happened. So you describe, you know, and they invaded this country and they fought bad and then back, and then this man became the king. So in that case, it's not science, even though it's useful, it's you know, it's insightful, but it's not science because it's not based on the scientific method. It's merely a history, so a record of what happened. Similarly, description. So you can be describing how things are done in a company, XYZ, whatever it is, or maybe even comparing, you know, how things are different from, you know, in the United States versus Japan. But again, it would be more a description of what is, but not a test of certain, you know, relationship that you believe exists. And so unless you're testing something, unless you have a hypothesis and you test it, it would be just that, description. And description may not be bad. Like, for example, now I'm going through this podcast, wonderful podcast, probably the best one I've heard so far, called Business Wars. So it's available on every podcast platform. And so it talks about, right, like, for example, Blockbuster versus Netflix, McDonald's versus Burger King, Apple versus Microsoft. Wonderful stories, very, very insightful, extremely useful. Like, for example, I just finished McDonald's versus Burger King. Like, I didn't know many of the things, you know, for example, that propelled McDonald's, you know, ahead of its rivals. So it's very useful, it's very educational, but the podcast, it's only a description of what happened, kind of mix of history and description. It's not science. So they're not making any sort of predictions or theories why X affects, or that X affects Y, or whatever other relationship or difference they're talking. They're merely describing things. And so in that respect, it's not science, it's storytelling. Classification. So you may discover that there are, you know, classes or types or groups of something. And so again, very useful, you know, like, for example, this theory of team development, forming, storming, norming, performing, right? And then adjourning in some models. Very useful. We know that that seems like what, you know, the way teams develop, but that's not a, you know, scientific theory per se. It's only a classification. And I suppose it could be tested, but to my knowledge, it hasn't been really tested in that way. And so it's more of a classification, which is not science per se. So again, just something to keep in mind, especially if you're developing your studies for this course, but also for your dissertation. Now, in terms of where I get my data, I'll just go quickly through some of the things. You probably know them, but importantly, plus and minuses. So archival data, it doesn't really have to be in an archive, like a building archive. It could be any organizational records, any existing data. And so that's a good thing because you have the data that you don't need to collect, so they're all already available. But obviously the negative here is that, you know, whatever data are available, that's what you have, and maybe that's not necessarily what you need. So maybe some of the questions were missed, or maybe some of the measures were not the way you wanted to measure it, or some of the variables are missing. So archives are good, but they are, you know, what they are, and sometimes you may need something slightly different. Observations, again, when you observe something, very useful. You learn a lot, you see everything that's going on. But again, in many cases, it's costly. You don't have time to observe, you know, for a long time. Some, for example, business process, it may be developing over years. And often you don't have the opportunity to manipulate, you know, you cannot really test things, you just watch. Interviews and surveys, that's pretty much mostly how we collect data these days, or most of the time. And so very useful. Interviews allow you to go much deeper. You can ask and modify questions as you go. It allows you to get much richer data. But the negatives obviously are in both cases that you rely on people telling you whatever you want to hear. And so people sometimes may not know, or sometimes they may be mistaken, or sometimes they may not remember correctly, or sometimes they may not have the expertise to properly evaluate what's going on. And sometimes they may just simply lie, maybe even subconsciously. Maybe they just, you know, say things that make them look good. And so they don't even realize that they give you, you know, basically misinformation. So again, next time we will talk much more about surveys, proper way to design it, to check for all these problems, but useful, you know, like democracy. You know, democracy is bad, but we haven't invented anything better. Same thing with surveys. Surveys have so many problems, but unfortunately, in most of the cases, there is no better way to collect data. And then
Awesome.
yes, go ahead.
I have one quick question on that. So I teach classes at UNC Chapel Hill. Many of my colleagues that I teach there or I work with, they all talk about they use external providers to give them their data. They say, oh, we just get grants from the university and that's how we get our data and that's why we publish so much more. Is it frowned upon to continuously go out and buy and use a third party to do your data collection for you?
Yes and no, and it depends on, this is an excellent question, and I'm so glad that you asked. I actually should have added a slide on that. So in theory, it doesn't really matter who collects your data, you or somebody else. And if you have the money and you hire someone to do it for you, why not? Maybe even, it's a preferred way because maybe they are professional. Like, for example, when we were establishing this specific program that you are in, part of the approval process requires so-called establishment, we had to establish the need. And so for your program, what we did, we hired an external company, consulting company. And so they surveyed every person in the state who was teaching but didn't have a PhD degree. Like literally, they went to all 16 campuses, to like a few dozen of community colleges, and they literally asked the question, so if this program was available, would you enroll in it? And then to my surprise, something like 70% of the people responded. So we had like over, I don't remember the exact number, but it was huge sample size, like hundreds of people responded. And most of them said either, yes, I would enroll, or it's too late for me, but I wish you were available 20 years ago, something like that. And so in this case, we didn't conduct our own data collection, but somebody else did it for us and they had the infrastructure. And so that way it was fine. So no problem with that in that respect. But I'll tell you this, so in my undergraduate and my master's, I was more or less in economics. So it was first pure economics, then it was political economy, so government program analysis and stuff like that, evaluation. And so at that time, I was among the economists, and economists, they always use existing data. So they always go to all of those, like World Bank, United Nations, the Ministry of Education, whatever, sources, archives, the school district data. And so they use existing data either, that exist in archives, or in many cases, they do hire a third party. And then they get their data set and they run the analysis. And economists especially, they are completely obsessed with methodology. Like if you take any of the papers published in an economics journal, you'll see like 3 pages of formulas first, and then you will see the actual results. Like we don't really do that in management. They would have these fancy formulas, and they would have, like for example, when we run a regression, we usually just run a regression. They would always have all those corrections for heteroscedasticity and homogeneity and, multicollinearity, and they would run like 25 different, tests that they do. And so that's all good. And I thought that was, the way it is. But then for my PhD, I was at a business school, but it just happened to be so that I took about half of my classes at the psychology department, because I was more an OB HR guy. And so I had to take psychology classes. And so in psychology, they are much, much more obsessed with data collection. So they are all about experiments, all about surveys. And so a good half of all the training they get is literally in psychometrics and survey design. So they're very, very careful about, all those, ways to design an experiment, ways to design a survey. And so when it comes to the analysis, hardly ever do they go beyond like t-tests or maybe like simple correlations or ANOVAs. But they're very, very particular about the data collection. And so what I discovered is that economists often are completely oblivious to the problems embedded in their own data. So like, for example, when it comes to culture, economists sometimes use Hofstede's data. And so they love it to have a list of countries, and then let's have GDP, for example, and then like cultural, individualism, collectivism, power distance. And they absolutely don't care what those data represent and where they came from. And so only when you start taking classes in that, data collection and data design and, survey design, you realize that it's almost like, like a hot dog, as they say. Sometimes you don't want to know what happened to it before it got on your plate, because if you knew, you wouldn't eat it. And so with the economists, and that for that matter, that's why I look at those people who use third-party data, where they hire someone. Sometimes it almost feels like that. So they want this nice, piece of meat on their plate, or hot dog, but they absolutely don't want to know what happened to that, cow before, like from the farm to the plate. And so my problem here is that the data tend to be bad. In fact, in many cases, when you look at data, any data that is published, you immediately start seeing problems. And so I would prefer to have my own sort of control, or at least know what's going on and how the data are collected. So therefore, I would prefer to collect my own data if I can. If somebody else does it for me, I may not have a full knowledge, full information, full control over how the data are collected. But again, overall, I don't think it's really a big issue. So if you have money and if you have very specific, like if you design your survey, just somebody else goes and collects the data, I suppose why not? I mean, that's wonderful. Data collection is so time consuming. So why not save some time here? I would be worried about outsourcing this specific important, the expression garbage in, garbage out. So I wouldn't want to end up with garbage data, because whatever you do then, it just doesn't lead to anything. But yes, I suppose if it's done right, why not? Why not save some time and outsource it? So now experiments. All I will say is that probably the most important methods course that I took was research design. And research design primarily deals with design of experiments. Until then, I had no idea that it's a whole, like you cannot even cover it in one course. Like the textbook is really a thick textbook, research design, and it covers so much. I mean, there is so much more to experimentation than normal people think. People think that an experiment is that, you mix something and it makes, some green smoke, and that's the experiment. Or you have a hypothesis, you collect the data, you manipulate something, have two groups, and then compare the results. No, experimentation, that's a whole science. Like it's almost like music. They have their own notation, to describe the experimental design. They have their own sort of language. Very, very interesting, extremely insightful. And as I said, I took it as one of my last courses, and it probably should have been one of my first. And so looking back, again, I always thought first I wanted to, should have taken it much earlier. And second, gosh, I'm glad that I took it, because I don't understand how one can graduate without that course under your belt. So if you haven't taken experimental design or research design, I very much recommend at least buying a textbook. And there are a bunch of textbooks, all standard. I mean, just like any statistics book, they cover the same list of topics. It's a very old developed sort of discipline. But you will learn there, about all kinds of type of experiments, all kinds of research flows, how to denote it on paper so that you know exactly how things go. Very, very useful. So all I'll tell you is, for now, is that there are sort of two types of experiments, true experiments and quasi-experiments. And true experiments almost never happen. So it's almost impossible, hardly ever possible to conduct a true experiment unless maybe you're in natural sciences. You have much more control over your, whatever you mix, like physical objects that you manipulate. But when it comes to our field, management, psychology, education, economics, strategy, in most cases, we cannot really do a true experiment because it requires, for example, random assignment to experimental conditions. So looking at, for example, the hypotheses that you sent to me, I don't think it would be possible to test most of them experimentally, from a practical point of view. Many of them, for example, of you hypothesized, like if the company does this, this is what will happen, performance will improve. To do that experimentally, you would need to have a bunch of companies. You would have to randomly assign half of them to do, to engage in strategy A, the other half engage in strategy B. And I don't think it's realistic. I mean, unless you have too much money and you want to hire and create those companies and test it, it will be just too timely, too time consuming, too costly. Nobody will sort of engage in that kind of experiment randomly. So all you can do is maybe observe what happened in the past, but that would be a quasi-experiment because you don't really, randomly assign your subjects to the conditions. So there is a control group. And again, in many cases, that's not possible. Like if you wanted to, for example, see how, compensation, one of you was talking about compensation, how that affects performance. Well, you can see if more compensation helps, but I don't think you can have a control group where there is no compensation per se, for example. So, so it's not always possible to have a control group. It's not always possible to have full control over treatment. So true experiments are difficult. So what instead we usually do is we do quasi-experiments. Like, for example, we do a natural experiment. We look at something like, for example, my kid now is doing a study on the effects of drug legalization on crime rate, on health condition of the people, and what was the third one? And economy. So basically, is it basically improving the state budget? And so he's using a natural experiment. So as you know, in the latest election, several states basically approved some drugs like cannabis And I believe there were some, like Oregon apparently approved, or Washington State apparently now decriminalized almost possession of almost all drugs. And so here, you know, a proper experiment would have been that we would randomly select 25 states and legalize drugs, and in the other 25 wouldn't, and then see if there is a difference in all those outcomes a few years later. So we cannot do it that way, but we can observe that, you know, some states seem to have randomly passed, or not randomly, but passed those different, you know, more relaxed laws. And so we can observe what happens in those states versus those that didn't. So we didn't really have a random assignment, but we sort of have a control group, we have a treatment group, and we just observe the difference. So in many cases, those are either pre-existing groups or maybe some self-selection bias that may be there, or maybe participants are not really blind to what kind of experiments we're doing on them, so they know what the experiment is. So in this case, it's not really a true experiment, but it's close enough, and so we basically, you know, are happy with that. So again, highly recommend to read more on research design. You will never ever regret that you spent whatever days you spent reading that book, I guarantee you. One quick differentiation between cross-sectional versus longitudinal data. Again, as you will be designing your studies, especially if you want to study something, you know, like change over time, you will have, again, two choices. There are longitudinal versus cross-sectional data. And I'll give you an example to illustrate what the difference is, and you probably know. I'll just say that, again, in many cases, longitudinal data are hard to come by. If you want to collect your own data, in many cases, you just don't have the time to wait and see what happens. If you're using archival data, in many cases, the way things were measured year from year, you know, from one year to another, maybe the measures changed. And so while you have many years of data, it's not directly comparable. Or maybe the people who participated in the survey, you know, it was a different sample each time. And so it's very difficult to have true longitudinal data. But cross-sectional in many cases can be suitable for example, studying change or, you know, differences over time. Like, for example, for my dissertation, I believe I mentioned in the previous class, I wanted to see if a person's work-related cultural values change over time as they immigrate into a new country. And so in the proper longitudinal design, the way I should have done it is I would have had, let's say, 100 people or 1,000 people, and I would literally measure their cultural values at the time when they land in the new country. And then I would conduct the survey again every year, and I would see if the data, if the results change from year to year. I didn't have those years, 20 or whatever years I would have needed to do it. So I went with the cross-sectional design. So what I did is I found 100 people. I think I actually had more like 2,000 people, but 1,950, something like that. But in that sample, I had some people who just came to Canada, like literally landed a few days ago, and then all the way, you know, people who were there for a year or for 2, for 3. And I think there was one immigrant who was at that time there for like 45 years at the time when I surveyed the person. And so that was a cross-sectional design that allowed me to sort of kind of conduct a quasi-longitudinal experiment by looking at the duration. Not perfect, because maybe people who came to Canada 40 years ago were different from those who come today. Maybe the conditions were different. Maybe the pace of change was much faster in the 70s and much slower now. But that was sort of the best I could do. And so I used a cross-sectional design to kind of study longitudinal change. So.
Ross, can I ask a question on that?
Mm-hmm.
You know, we have to look at sample size, and you know, we're always looking at what is the smallest sample size that you can use, you know, an N of 30 or something like that. In that case, is your N still the number you're looking at, or is it that each group, you know, or is it because you have such a steady in the design you showed, 1 year, 2 year, 3 year, there's such a steady row that maybe those would even out?
That's a very good question. And again, first, the required sample size differs from from method to method. So in some, or usually they say about 30 cases per variable, but sometimes 10 may be enough. There are corrections you can do when your sample is too small, too large. But the level of analysis is critically important. Several of you in your proposals talked about behavior in teams. And so it's very important to remember, are you studying teams or are you studying individuals? Like, for example, one of the studies deals actually with cultural change in teams. And the hypothesis is that as people spend more time together, their values will become more alike. And so the big question here is, so are you then going to measure individual change or change in individual values over time? Or are you going to measure the sort of the variance or standard deviation of those values within the team? And so both ways are possible depending on what exactly you want to say, but it's a critically important question. So if your hypothesis is that it's not really important how those values change, what's important is that they become more alike, then essentially you're talking about variance within the group. And so essentially the group becomes your unit of analysis. So in this case, your sample will be sample of teams, not sample of individuals. But if you want to see, for example, if those individuals' values change towards certain, like for example, maybe to the values of the, let's say, people from the rich country on the team, then in that case, you will be looking at the individual change. And so persons will be your sort of units of analysis. And so your sample will be a sample of people who happen to be in groups. Maybe you will even control for the group effects, like maybe using some multi-level analysis, but individual will be your sort of, your subject of study. So it's very, very important to keep that in mind. Very good question. Now, we will not be talking about meta-analysis in this course, but it's one of a very, very, probably one of the most, not the most important, but a very important, powerful method. And I'll briefly explain to you what a meta-analysis is, just as a, basic principle, in case you ever want to do one, so it may not be a bad idea. And I believe actually one of you is thinking about doing something more like a meta-analysis, because the study requires, first of all, by doing a meta-analysis, you kind of survey the field. You learn about what's been done already. And so it's a very, very good idea to, like, for example, I started my academic career with meta-analysis. So my first 3 maybe papers were meta-analytic papers. But what that allowed me to do was to survey and learn anything and everything that there is to learn about cross-cultural management. So it provided a very solid foundation before I could venture on with my own studies. So a very good idea to do it if, if you're thinking about maybe, kind of venturing into a new field. But so in brief terms, there are again thick books about meta-analysis that explain how the methodology works, how all the calculations work. But in a primitive way, what meta-analysis is let's say, for example, you would like to study or explore the relationship between income level and education level. And so in a traditional conventional research, what you would do for that is you would get a sample of, let's say, 100 people. You would, I don't know, ask 100 of your friends. 1, how much money do you make? And 2, how much education do you have? And then once you have those 2 variables, you will just calculate a correlation, and you will say, okay, maybe the correlation is, let's say, 0.2. So the more education you have, the more money you make, and the effect size is 0.2. So you calculate that correlation. Meta-analysis is slightly different. So here, instead of surveying your own 100 people, you look if somebody already did those studies. And so maybe you find that there are 10 papers, published papers, that already answered that precise question. So they did, go out, ask people about their income level and education level, and calculated the correlation. And so in the most primitive way, your meta-analysis would be literally like an average correlation across those 10 studies. Let's say one of them found a correlation of 0.1, another one found a correlation of 0.6, another one found a correlation of 0. So you take the average, and let's say on average it comes out to be 0.3. And you say, well, I don't have to collect my data because I found those 10 studies and I basically took the average. The rest of the meta-analysis kind of deals with special cases. Like, for example, you discover that some of those studies that you found were based on, let's say, a sample of 100 people. Another one was based on a sample of 1 million people. Another one was based on a sample of 5 people. And so you realize, well, I can't really take just an average because, one study was much bigger than the others. So maybe I need to sort of weight my results by the sample size. And so you assign more weight to those studies that had a bigger sample and less to those that had a smaller sample. Then maybe you realize that some of your variables were measured differently in different studies. Maybe in one study, the education level was measured as years of education. In another study, maybe it was, for example, the highest degree attained. Maybe another study didn't even do a correlation. It just did the difference in income between those who had high school only and those who had a college degree, for example. And so they calculated the D-score difference. And so what you do then, you convert all those statistics into one specific type. Let's say you're looking at correlations or maybe D-scores. And so after all those transformations, you can then calculate your average effect size. And many other manipulations, corrections, correction for unreliability, all kinds of things that sometimes you need to do before you can get that final average number. Plus, you calculate all kinds of additional statistics like your confidence intervals, your credibility intervals, the number of studies that would need to be found to have a 0 effect to invalidate the conclusions that you did, all kinds of things like that. So, but that's essentially the method. And so here is how, for example, I did my very first meta-analysis. So it dealt again with cultural differences. And so I wanted to see if cultures of, let's say, Americans, Chinese, and Brazilians are different. And so in the traditional way, like for example, the way it was done by Geert Hofstede, sort of the father of the cross-cultural management. So what he did was he went and found a bunch of Americans, and then he gave them each a survey and asked them to answer a bunch of questions. And then he tallied up those surveys and got some sort of an average for the United States, let's say on individualism. And then he did the same thing for China, and again, got their results, tallied it up, and got the average number for China. And then same thing for Brazil, for example, and then got the average number for Brazil. And then he did it actually for about 40 countries that way. And so he got his average cultural values for Brazil, China, and the US. By the way, one of you had hypotheses about culture. Wonderful, great, nothing wrong with culture. Just remember that culture, it's so big that you cannot really measure culture. You can measure specific things like, for example, like dimensions of culture. When we talk about values, could include like individualism, power distance, uncertainty avoidance, things like that. Or maybe if you're talking about organizational culture, maybe it deals with the type of, like authority, or, flat organizational structure or steep organizational structure. Is the power concentrated on the top, or it's more kind of evenly distributed? So you have to talk about specific attributes of culture, not just culture in general. So, but anyway, that's how the research has been done on culture in general. So what I did the same thing, but instead of measuring people or surveying people, I looked at studies that already did it before me. And so I found about 1,000 papers, and let's say 400 of them look at cultural values of Americans. And so they already reported those average individualism levels. And so instead of using my own sample, I just basically averaged what those studies said. And so that was my American sample. And then the same thing for China, and then the same thing for Brazil. And so I basically had almost 1,000 studies conducted on this topic before me. And using data from those studies, I was able to take sort of, calculate the average cultural values for, in my case, I think it was like 49 countries. And so that's what we did there. So I don't know if any of you are planning to do the meta-analysis. Anyone ever thought about doing one? I don't know. So it's
yeah. So we do a lot of those in medicine, but that kind of
yes. And in fact, medicine was very, very. They didn't really develop the methodology, but medicine is probably the biggest on meta-analysis. Like they produce so many of them, and that's great. That's important because so many little studies are done all the time. So you always want to integrate all of that, because individually you can have how many patients? I don't know. Let's say a few thousand. But probably thousands of other teams have done the same experiment. So meta-analytic integration allows you to look at the bigger picture. Very good example, yeah.
Yeah, the challenge is finding homogeneous data. So we did one, we did one a couple of years back. I think it was published in 2014 or something like that. And we were looking at special tests, essentially physical examination measures to come up with a diagnosis. And we found a couple of studies, but the problem was they all compared to different things. Like one compared to X-ray, and one compared to MRI, and one compared to CT scan, and one compared to, and they all compared to different things. So we didn't have homogeneous data. So at the very end, we largely produced a meta-analysis, but the reviewers wouldn't let us call it a meta-analysis because it was so heterogeneous the way it was set up.
Yeah, that's precisely the case. And my kid is doing his meta-analysis. In addition to that, observing what's going on, he's also looking at countries that legalize drugs, like, Portugal, and then Oregon did it a little bit earlier. And so there are a lot of studies on the topic, but one problem he discovered in kind of medical related stuff, every state, every country, first, the laws were slightly different. So it's not like they passed exactly the same laws. Second, every country has a different, like economic conditions, crime rate to begin with. So not quite, sure if you can compare them directly. And then when it comes to, for example, health cases, like overdose and whatever else, emergency calls, everybody does it differently. Everybody calculates it differently. And so it's not always possible to just simply integrate it together and to take a neat average. So when it comes to medical science, I can only imagine how many factors play there, like, maybe the sample was of different age, maybe people had different conditions to begin with, maybe they were subjected to different treatment, maybe, and so it's not always possible to directly integrate that, but there are ways to correct for many of those differences, and so meta-analysis definitely help. The only problem with meta-analysis is that it does take a lot of time to collect the data, to find the studies, to code them, so it is time consuming, tends to be time consuming. And going back to Joe's question, it's common to use students, graduate assistants, to help you with data coding and search for data. Because yes, if you needed to do it all yourself, it's very, very time consuming. So I suppose there is really no problem here hiring external help. But then again, especially if it's, graduate students, in many cases, they may lack qualification or, expertise, or maybe even motivation to do it well. And again, you can risk, saving time, but getting some data that are perhaps not entirely accurate. So, all right.
So Voss, would you ever do meta-analysis as part of dissertation work? Because I'm just thinking, with the new dissertation style of trying to develop 3 different papers that are publishable with empirical work, I mean, or would that just be like too insurmountable to try to work into your dissertation?
You know what? I would say, Christy, that the perfect 3-paper dissertation, in my view, would be paper 1 is the theory. So you develop the theory. Paper 2 is a meta-analysis. So you basically test the theory by the means of the meta-analysis. And then paper 3, you find something new that those prior studies didn't address, and you do your own empirical study. The challenge here is that the meta-analytic study will probably be the most time consuming. And so do you have the time for that? And the answer to that is, well, it depends on what you study. Like, for example, for my research, I was looking at culture, and I believe it was like 870 something studies for the first paper. And so coding those papers, downloading them, reading them, it was a huge, huge amount of time. And so looking back, maybe it was not even, the wisest use of time, while I had to work on the dissertation. It turned out just fine, but it was many months of basically doing nothing but reading those papers and coding them. But then if you're looking at something else, maybe something that is less popular, and maybe there are really only like maybe 25 papers that you can find that did it, in that case, it's really not going to take that much time. So Google now allows you to relatively fast, to find those studies. You can get the full text PDF pretty much the same day. Like in my case, I literally had to order like a paper copy of some papers through the intralibrary loan at that time. And so that took some time. Today, you can, if it's a topic that is relatively new and there have been not many studies, you can probably find all your papers like in one day. Maybe, then next day you just check one more time with a fresh kind of mind if you didn't miss anything, but you can have your PDFs literally in one day. And then if it's only 25, 30 papers, you can probably code them, if not in one day, then maybe let's say in 5-6 days. So it shouldn't be too difficult. I mean, it's only 30 papers. You just read them and you record the data. In that case, it actually may not be a bad idea at all to do meta-analysis. The only, again, challenge here is that the method itself is a little bit complicated. It's not like you open Stata or SPSS, plug a bunch of numbers, and that's it. Nothing super difficult there either. It's like not really complicated math, but you'll probably need to, at the very least, read the book on meta-analysis first. And usually you need a separate software. I think R does it, but there are literally, at least in the one I use, it's a self-standing meta-analytic software. So if it looks like it's not a huge field and it's going to result in, let's say, I don't know, let's say 100 papers with the topic that you need, and of those 100 papers, let's say only 30 papers are expected to have the data that you need, which usually happens to be the case. It's usually about 25% or so of the papers on the topic that actually contain original data. The others just talk about it, but don't really collect the data. Then yeah, maybe why not? As I said, it will definitely put you in a position where you will know everything that has been done on the topic so far. And if you plan to do more research on it, it's definitely the best way to prepare, because you'll probably need to read those papers anyway. I mean, like, you'll still need to do a literature review, you'll still need to familiarize yourself. So why not do it as a meta-analysis and, publish it as a separate paper? So
there's a bunch of ways to make it smaller though. I mean, I agree. Like if it's too big, if it's so many papers, you can't do it, right?
Yeah.
But you could do it. You can refine your research question. Okay, I'm only looking at resource-based view of the whatever theory, but I'm only going to look at it in manufacturing, and I'm only going to look at it in medium-sized businesses. And you can see, and even then, if it gets too big, if it is so big, chances are someone has done a meta-analysis on it before. And in which case, okay, you did it in 14. I'm going to do a meta-analysis in the last 7 years and just look at the last 7 years. And it's almost like an update from what has happened since the last one. So there are even if it's big, there are ways to kind of chunk it out and still get really good results. And then I don't know how it is otherwise, but meta-analyses in medicine get like all the citations, and then all the original studies, like here was the original study. This was a big piece of your meta-analysis, but I don't get cited anymore because your meta-analysis has kind of like taken my thing into yours. So so it's a really good way. There are authors I know that do nothing but systematic reviews and meta-analyses, and when you look at their authorship metrics, they're like ridiculous.
Yeah, that's exactly right. Yeah, all my like literally out of my 3 most cited papers are meta-analytic papers, and it's almost unfair, but yeah, people love meta-analysis because they sort of integrate all of the known. Here, the trade-off though is that usually the bigger the better. So kind of the value of the meta-analysis is that it incorporates everything. But yes, you can always slice and dice it, and so perhaps even I would kind of narrow it not even by the question, but by the measure. Like for example, in my case, I had so many papers because I included every paper that measured cultural values using any instrument. But had I limited it only to Hofstede's value survey module, I probably would have cut my sample size in half, if not more. So in that way, it's easier for you because you don't need to do too many standardizations of all those measures. Like going back to this income and education. So maybe you'll look only at the studies that looked at income as annual salary and education as years of education. So all those other studies that looked at other ways, you just exclude them. So that may allow you to keep it more standard. So yeah. All right. So now a few words about types of data. And so there is really nothing unusual here for you. You know that there is qualitative data and quantitative data. And when it comes to qualitative data, we can be looking at like results, transcripts of interviews, observations, case studies, ethnographic data. When it comes to quantitative data, you can have continuous variables, percentages, ratios, ordinal categories, and stuff like that. So what's important, the reason I'm mentioning it here is that in most of the cases, most of the methods, they have specific assumptions about the data. Like for example, probably the most popular method that we all use would be correlation, t-tests, regressions, HLM, structural equation modeling, ANOVA. All of them are from the same family of methods, and they all use very similar math. And so all of them assume that your data are continuous. So basically you have a scale that goes from negative infinity to positive infinity. It doesn't necessarily have to include the entire spectrum from infinity to infinity, but it's continuous data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, properly spaced. And so it also assumes that your data are normally distributed. So when you plot your cases, you'll have this bell curve. And then it also assumes that the data are not truncated or censored. You understand the words truncated and censored, right? Like truncated, everything that was below certain level or above certain level was not included in the data set. Like for example, maybe if you wanted to look at education versus income, you will not have people there without, like with less than 12 years of education because everybody or almost everybody has high school. And so you basically have truncated data because it's just not available there. Or if you look at, for example, the effects of, let's say, GMAT test scores and your GPA. The problem is that there is a maximum that you can get on your GMAT or SAT, and so it basically becomes censored. So if somebody is a genius, they still cannot get 10,000 points. They can only get 1,200 or whatever the highest possible score. And so here you have censoring. So once you reach a certain level, you kind of have that, glass ceiling, so to speak. So then it also assumes that the error of your measurement is random. You have homoscedasticity and non-collinearity. Doesn't matter what that is. The point here is that it's not always the kind of data you have. So like, for example, recently we did a study where we wanted to see if the university rank predicts performance. And so university rank, it's not continuous data, it's rank data. So it's not 1, 2, 3, 4, 5, where the space between 1, 2, 3, and 4 and 5 is the same. So the universities ranked 1, 2, and 3 may be almost identical. There was maybe like a 1 micron difference, but we just forced it into number 1, number 2, number 3. So the data are not normally distributed, and so you cannot use regular regression. You cannot use regular, correlation or whatever else because that's not the type of data that it was designed for. So your variables or your conclusions will be skewed or biased. And so the important thing here is to keep in mind that there are all those different types of data. And usually once you have something different than continuous variables, you have to use a different methodology. Like we will be talking about logistic regression. So that's when you're trying to estimate the probability. So between, let's say, 0% and 100%. as opposed to some sort of a continuous variable outcome. And so it's a very different, not extremely different, but it's a different type, different methodology. Same thing when you work with ratios, when you're trying to estimate a ratio of something, or if your predictor is a ratio. Again, you cannot use the usual OLS regression that we love so much, because it's really not designed for those kinds of data. Or if you have like dummy variables or nominal categories, you can use it with regression, but you have to add them as a set of dummies as opposed to just, 1, 2, 3, 4. So we'll talk about some of those things, but it's important to keep that in mind, because your method may not provide proper conclusions or valid conclusions if you use a wrong method with the type of data that you have. So and then finally, are my data any good? So again, next lecture, we will talk about specifically evaluation of data quality. So we'll talk about all those validity tests, reliability tests, so all those kinds of things. But briefly, again, once you have your data, and that's going back to the question about third party. So at the very least, when you get the data from them, you want to conduct them to all of these tests. Like, look at descriptive statistics. Are your minimums and maximums and averages where they're supposed to be? Like, for example, in Xculture, we collect tons of data, and in our big data file, we have minimum, maximum, standard deviation, and average at the top of the row, so I can see right away if something's out of ordinary. Like, for example, if it's a Likert type scale where you have like, do you agree, disagree from 1 to 5? So if I see a number below 1, like 0, that's immediately signals a problem. So a 0 is representing missing data, a 0 is just something wrong, so something's not right. We found actually yesterday a mistake in the data set. So it was one of those 1 to 5 scales, but then I started noticing that we had some values that are 6 and 7. I'm like, that's strange, what's going on? Turns out that Qualtrics, the data, the tool we use to collect the data, every time you change the statement that represents 1, 2, 3, it kind of adds it as a new option. And so we made a change for option 3, like basically neither agree nor disagree. I think we changed it to neutral. And then 5, we changed it from very to extremely or something like that. And so instead of just changing the enter name, it literally added it as option 6 and option 7. And so people who chose 3, it was recorded as 6. People who chose 5, it was recorded as 7. And so only when I looked at my descriptives, I was like, yeah, that's strange. It shouldn't be 6 or 7. It was a 5-point scale. And so, and again, sometimes it's not easy to spot because you forget if it was a 1 to 5 scale or 1 to 7 scale. So important to inspect, do those kinds of inspections. Generalizability, again, a very common concern that I hear from, with respect to the Xculture data. So our study participants are primarily MBA and undergraduate business students. And so, but most of the research we do is on sort of business teams. And the question becomes, are these students, representative of the general population of the working, people? So office employees, for example. And so maybe as people get older, as people maybe, I don't know, get married, have a real job with a real salary, maybe things, the way they see things and the way they do things is different from how they do it as, while they're students. And so maybe whatever relationship we discover in this sample, maybe they would not generalize to, for example, office employees. So very important, and there are, again, ways to test for generalizability. There are all kinds of mathematical ways you can do it. Like, for example, if you believe that, let's say you want to study how political views affect performance. The problem is that if you do it with a sample of students, your sample may be much younger than the actual population that you want to generalize those findings to. And so you're not sure, maybe, as people get older, maybe they change their political views. Maybe they become, I don't know, maybe over time, one politician said that if you're young and not Democrat, then there is something wrong with you. But if you're old and not Republican, then there is something wrong with you, something like that. And so maybe people, in their 20s are more likely to be liberal.
For sure.
Yeah, exactly. But then as they get older, maybe they're more likely to become conservative. So what you can do is you probably will still have some variation in age in your sample, even if it's only between, let's say, 20 and 30. And so you can then use age as a covariate and see if it's really true that older people become more, let's say, conservative. And if so, then there are ways to adjust for it. So even your sample did not include anyone above 30, but you still see the trend and you have, we can make that correction. So there are methods for that. Missing cases, big deal. Like, so are they missing randomly? Is there a sort of like selection bias? You know, maybe people who didn't answer those questions, maybe it's not because they just forgot randomly. Maybe, you know, they were not comfortable saying that. And so as a result, maybe there is, you know, a problem. There was an interesting story from Ukraine a few days ago. They said that there is no sexual harassment in Ukrainian universities because the researchers left like, you know, like a boxes where, you know, you can submit a complaint or share your case of sexual abuse. And nobody, like 0 people submitted anything. So from which they made the conclusion that there is no sexual abuse. But I mean, maybe that's, you know, the case of missing data where people just were not comfortable sharing that. Or maybe they didn't trust the researchers, or maybe, you know, whatever else, stigma. And so missing cases may not necessarily represent random missing cases. Maybe the fact that they're missing it actually tells a bigger story. And then obviously, so what do you do with that? So if you have a missing case, do you then just plug in an average? Do you delete that whole row of data? Do you plug in missing data using so-called regression inputs? So there are all kinds of ways to correct for that, and you know, or you know, ignore it in it, or you know, drop the data. But it's very important to look at that. Outliers, again, you know, you're trying to prove that X, you know, like I don't know, certain personality trait affects performance. And then let's say you have this individual who is very high on, let's say, extroversion, but then shows very low whatever performance you're trying to measure, very unusual. And so is it because the person was just lying? Is it because maybe the person was in bad mood or maybe drunk that day? Or is it, you know, a legitimate case? I mean, and so do you delete those outliers? Do you use them as useful statistics? So there are even ways to test if outliers were kind of deleted in a way to get the results that you want. And so very important, big issue, and you will struggle with that a lot. And as I said, sometimes when that outlier, you know, kind of supports your conclusion, you're tempted to keep it. But if that outlier is kind of messing up your conclusion, making everything insignificant, or the relationship turns into a different, you know, from positive to negative, then you're kind of tempted to say, oh yeah, this guy must have been, you know, in a bad mood on that day, so we definitely want to exclude him. So very easy. And then statistical power. So back to the issue of sample size. If your sample is too large, then yes, everything will be significant, and it increases your chances of type 1 error, increases your chances of concluding that A does affect B, when in reality it may not. But if your sample is too small, that it may be just so small that you cannot even achieve that statistical power to detect the relationship. So maybe there is a relationship, but it's so, your sample is so small that it just doesn't give you the necessary statistical significance, and you're basically set up to make the type 2 error. So very important. And then obviously, you know, the validity and reliability of the actual instruments of the measurement, surveys or stopwatch or whatever you use, but that's something we'll discuss next time. So there is much more. And so we'll devote a whole lecture to this issue. So I've covered all the major things that I wanted to cover today. Any comments, any questions, any observations of your own? Now, I would like to say a couple of things. One of you sent me an email saying that the person doesn't want his or her work shared with the rest of the class. And I forgot who that was. I went through all of my emails. I couldn't find it. So I did share the work. And so the reason I did share is because the person said I wouldn't be comfortable because I'm not a very good researcher. But this time everyone actually did a pretty good job. Like everyone did a good job. And there were a few cases where there was like option 1, option 2, and maybe one was much better than the other, but at least one was good for everyone. And so I felt that there is really, this time there was nothing that anyone should be embarrassed for. And so I thought I would share it, so take that risk. But if you're that person, if you're still not comfortable that I share your work, please send me another email. I'll make sure not to include that next time. Second, I didn't share the grades. I only shared your work and my comments. And as this, you know, I find it extremely interesting to look at your, you know, hypotheses and research questions that were much better than, for example, what we saw, some of them that we saw last semester. And I thought it would be very useful if you look at everybody's. It's only 15, I believe, people. So I think it would be extremely useful for you to read what other people do. So first, you may get some interesting ideas from their ideas. Like you look at what they want to study and you're like, oh, that's actually interesting. Maybe I can do it a slightly different way. Second, maybe you will find sort of courage to comment on it. And I strongly encourage you to comment, maybe share your thoughts with your team members. All of you had at least 2 options. There was one student who had like 8 different study ideas or something like that. You'll see that. And so maybe that person is struggling with selecting one best. So if you share your thoughts and comments, maybe that, you know, will help your classmates to decide which of the 2-3 options is the most promising one. And third, there were still some kind of recurring, I don't want to call them problems, but perhaps the way some of the hypotheses were stated was either too convoluted or perhaps not in a way that it would be easy to test. And so in a number of cases that, you know, proposed better or more kind of elegant wording, so to speak. And again, if you look at that again, maybe you are struggling with some of those issues. So my comments hopefully could be also insightful for you. So I send you the link to the whole collection. I encourage you to take a look. I think you will learn a lot. At the very least, you'll know what other classmates may be doing. And so maybe you'll team up to, you know, co-author a paper. There is this one student in the first cohort. I mean, amazing. So we just submitted one paper with her and another professor to a journal. And turns out she submitted another one as we, like, I don't know how she did it, like in one semester, 2 finished papers submitted to journals. So, but I don't know, she's trying to team up with as many professors as she can, but maybe there are people like that in this class. And so by seeing what others do, maybe you will choose to team up. Like some of these studies are genuinely interesting. Like for example, again, I'm not gonna name the name, you'll see it, but there is the study on the stock performance and publicity. So it seems to be so interesting, especially in this, you know, in the light of these whole developments about the GameStop and stuff. So I don't know, maybe some of you will find it so interesting that you'll approach the student and say, hey, can we maybe work together? Because there are several different ways the student phrased it. So there is one that looks at stock performance, another one looks at the acquisition price. And so maybe you'll say, hey, maybe let's look at it from a third way and can do it together. So why not? This way you can team up and, you know, a paper is a paper, even if it has 2 or 3 co-authors, but working together, you can produce much more. And so better to have sort of 2 papers with a co-author than 1 paper solo. And so from that perspective, I encourage you to take a look. All right, anything else?
I have a question.
Yes, please.
So our next class is the 17th, and then our next assignment's due the 21st. And I think we have to give you a list of data that we're going to use for our studies. So I have done a lot of research on possible data that I'm fairly unsatisfied with. So I'm wondering if you have any recommendations on the best places for us to, you know, in the next 2 weeks while we have to work on this, that we should start to get a good idea about data, what we should include in our project before we have our next class.
Yeah. One of the recurrent comments you will see in my responses to your work was that I was saying that it's an excellent idea, but I wonder if you can find good data. And so, as I said, some of the measures that you, or some of the constructs that you include in your theory are just difficult to quantify. Like, for example, one of the studies deals with design thinking. And so design thinking, it's an interesting concept. But and again, maybe I just don't know, but if I had to design a way to measure design thinking, like, you know, if the person or organization kind of has it or doesn't, or use it, or, you know, act, or I don't know, practices it or not, I would have a difficult time. So it would take me a long time, and I'm not even sure if I would come up with a good measure. And so one of the questions here is, so as the idea, it's brilliant, it's great, but will you be able to find good data, you know, to test it? Because I mean, how would you measure this design thinking, for example? And so in many cases, some of these, you know, papers that you proposed, the challenge will not be so much, can you test it? The question is, can you collect or find existing data that describe what you need? And so, as I said, you know, for some of the studies, like I wouldn't know where to even begin. Like, for example, again, going to the study on stock performance and publicity. So, you know, presence in media. So stock performance, that's easy. So we can look at public companies, we can see what they were worth on every day, and we can look for those days through Google News to see how many papers were, you know, articles were published about those companies on those, you know, in those days. So that's easy. But then when you go to, for example, a different twist of that study, the merger and acquisition price, that's where it becomes more difficult. So first of all, some of those numbers are never disclosed. Second, it becomes difficult because, you know, maybe the companies were sort of worth different to begin with. Maybe they were, you know, one was bigger, one was smaller, one was in a more profitable business, another one was not. So even if you can get the price of the acquisition, how would you parcel out the effect of media? Like, unless you have a gigantic sample, in which case you have companies of all sizes, then, you know, for example, size of the company may not be important here. And so you will still get some sort of an effect of media presence. But at that stage, it becomes much more difficult. So I'm not sure if it would be possible to find a good sample size where you can sort of, unless maybe you do some sort of case study and from that case study that initially the agreement was that it would be like, for example, purchase of PayPal. Originally, they started with about $500 million, but then eventually it became sort of in the news and PayPal became more known, and eventually they sold it for $1.5 billion. So in this case, you can say, well, as the company enjoyed more publicity, the price of the acquisition by eBay increased almost threefold. But I mean, otherwise, I mean, how would you do it? So it would be a little difficult. So Heather, what I would say to this one, we will talk more about data next time. So today we talked about it in general terms. Next time we'll talk more about specific, survey methods that you can use to collect data. And so hopefully that will be enough to give you good ideas for how you can measure your thing. But if not, it's a small class, so feel free to call me anytime. This week alone, I spoke with, I believe, 4 of you. And so that's fine because, in 15 minutes, we can discuss things much more in depth than, in 20 emails. So if you have questions, concerns about, for example, sources of data, just call me. Maybe we'll think about it together and, hopefully we'll come up to some conclusion. Second, for the assignment itself, maybe include every possible data source that you consider, and then I'll comment. And maybe for some of them, it will be obvious right away to me that, yeah, well, that's a good data set. I've seen that data set or whatever, archival source. And so, yeah, we know that it's legitimate. It's used a lot. So go for it. And maybe for others, we'll say, oh, yeah, no, Hofstede's data. Well, first of all, he never shared it. So you'll not be able to get it. Second, even if you did, it's problematic. So probably don't want to use those data. So maybe things like that. So for now, as I said, try to include or consider every possible source. And for the assignment, maybe even describe every possible source, and then we can either connect or I'll comment, or even before as you're working on the assignment. So if you want to connect with me, just call me on my cell and we'll go from there. So,
okay.
But yeah, data will be difficult. So for some of the studies, it's very clear, very simple. It's, like you just do a survey, maybe even of, fellow students, 50 of them, that's enough. For others, it may not be like, I wouldn't immediately know what kind of, like where could you get good data. Yeah. Christy, you raised your hand here.
Yeah, so I just want to make sure. So for the final paper, I had just pulled up the syllabus again. We are actually analyzing data. So we need to make sure that we have a data set.
We only, for this class, we only designed the research. I mean, ideally, we'd like you to analyze the data. And if you can get the data, it would be nice if you did it. In that case, I would be happy to sort of, look at your data, help you with the analysis, comment on your results. But the requirement is only the methods section. So you only design, you only explain where you would get the data, you only explain what analysis you would run. I think I even included sort of mock-up, or at least, some basics of the results section. You would say, okay, I'll provide my correlation table, I'll provide my regression results, I'll interpret these indices, but we don't really need, I don't expect you to actually do the analysis, or at least it's not required. But at the same time, I strongly encourage you, especially if it's something that you don't have to collect the data, or if you already have the data, I encourage you to try to run those tests. My job here is to sort of help you with your analysis. And so, as I said, there is always a problem, something doesn't run, or maybe the results don't make sense, or maybe, you discover that you have, let's say, multicollinearity. So what do you do with that? So if you have the real data, I'll be happy to sit down with you, take a look, and then hopefully help you, do it right. But if you don't have the data, because, in many cases, it takes time to collect the data, no problem, it's not required. So,
okay,
yeah.
Okay, thanks.
So like, for example, going back to that stock performance and media coverage, yeah, if you can, get 20, 30 companies and you can, collect those data, yeah, maybe let's try to do the analysis together. Sit down one day, or you run the analysis, I'll take a look at the results, or compile the data set and we'll connect and then try to run it together. So no problem. But then if you, let's say, want to do a larger sample, or you want to do meta-analysis, or some of you wanted to actually conduct surveys or experiments, I'm not sure if you'll be able to collect the data by the end of the class. So yeah, if you study teams, for example, we probably will have X-culture data, so we definitely can try. But for others, it may be more difficult. Yeah. All right. Okay, well then let's conclude here. So, yeah, I'll see you in 2 weeks. So yes, your next step is think about where you would get the data to test. So you had all of you had at least 2 data options. And so some of them I criticized and, kind of said it's probably not going to be practically possible to test it. Some of them I said both are excellent. So, but if you have more than one, decide which one you will use for this class. And for that one, think about where you would get the data. Will it be your own survey? Will it be an experiment? Will it be some sort of a qualitative observation, interview, case study? Will you find some archives or organizational records that you can use? Will you buy somebody else's data? Maybe even so. Maybe, and by the way, by buy again, I'm not sure what, was it Joe who said it? So doesn't necessarily have to be, you know, you hire a consultant company. It could be you use MChark, for example, and you pay people, you know what MChark is, right? Amazon's Mechanical Turk. So you just say, you know, for answering these surveys, I'll pay $2 per survey. And so you just put it on Amazon, and there are, you know, now by now thousands of people, hundreds of thousands who participate. And in fact, some made it their job. And so many of them, yeah, sure, I'll do a survey for $2 or $5. And so in that case, you have a grant, let's say $1,000, and for that you can buy like 200 people, you know, completing the survey. And so, and again, if that's what you want to do, the beauty of that is that you can get it done literally like in 3-4 days. And so if you wanted to do some sort of an observation, so maybe you can even, if you have the money and if that's what you want to do, maybe you can even get your data by the end of the course. So think about what you want to do, describe them, the sources. If there are more than one, list all of them and think about pros and cons and possible threats to sort of validity if you use each of those sources. So some of the things we covered today, we'll talk more about it next time, and then we'll see what you come up with. Well, good night, and yeah, talk to you in 2 weeks. And then, as I said, if any questions arise, it's probably easiest just to call me and we'll talk. So perfectly acceptable. It's a small group. We can do that. Okay, bye-bye, guys.
Thank you, boss.
Bye-bye.
Thank you very much. Good to see you, everybody.